Okay, so let's now try to demonstrate what we've covered under Splunk Search Processing Language. So we're going to look at things in terms of the syntax, the search pipeline, or the command types that we've seen. And note that this is just a demonstration where we're going to pick some random commands and then show how they work. SPL in itself is a very broad topic that you might need to learn, with experience or using the search manual in Splunk that has all these commands and the different syntax, just like with structured query language as we saw. So it's not like in one simple course, someone can teach you entirely like how you use SPL and all the different commands that are available. So here is just high level. Another important thing is that some of these commands are covered in the certification courses that you have. So in the Splunk Core Certified User exam, for example, you're supposed to know some transforming commands and whatnot, and then in the Power User as well, some of the different commands as well. So we are just going to cover high level some of them here. Now I'm going to start by just pulling data from one of the indexes that we use in our courses. It's actually data that's generated using the event gen app. We just place it in the main index and then we give it a source type of event gen. So I'm just going to go index main source type event gen. So main index basically meaning that we are having this data in the default index. So this is our index data. So basically here we are just pulling the data from our index. So for example, I could say that I only want events that have the term telco 04, for example. That will only pull events for partner telco 04. So events that have that term within them. So when you're looking at it, you see that everything that has been pulled here so far has telco 04 in there. That is an example of a search term. Or I can just say that, yeah, that's a partner telco 04. Okay. And then maybe something I could just even say, yeah, you know what? I just want events that have something like a 60 whatever. So you can use these search terms in order to pull events from your index. Again, we said that basic search is discussed under the Splunk Core Certified User course. So you have this, and then we're just going to go back here. We want to pull all the events. And we are going to start here by looking at streaming commands. We said streaming commands are commands that are going to act on all the data that you retrieve. So it acts on each individual event. In this case, when we go 60 minutes, we are seeing that we have over 23,000 events. It's going to act on them. But then distributable streaming commands are executed on the indexer. And then there are other commands like centralized streaming commands and others that we saw that are executed on the search head. So what you need to understand most of the time is that when you're writing searches, make sure that you put the distributable streaming commands first as applicable, because some of them might be commands that you really cannot put them first. Maybe you want to rename a field that was already existing in a statistics table, then you have to do it after a transforming command. But if you are not limited by something like that, then make sure that you put your distributable commands, the streaming commands first. So let's start with them. I'm going to go here, and since I've pulled my data, I'm going to execute my first command. Remember what we saw. Once you pull your data from the index, which is all this data that we have here, you execute the command. In order to execute the command, you put your pipe character. This can go on the same line. I just kind of change my settings so that anytime I put the pipe, it goes to the second line. So I have my pipe character here. And the first one I'm going to do here is to use a command called the fields command. Now, this command is discussed under the Splunk Core Certified User course. The fields command actually limits the fields that you are actually pulling from your data. So you still pull all your events, but then the number of fields that each event has is going to be reduced to what you actually specify. So you can use it to add fields, or either to add fields or to remove fields. When you see each event here, you see these are all the fields. So quite a few fields on the events. But what we are going to do here is that we are going to limit that only to like 6 fields. So I'm going to go and just say pull the field events, only pull a field response code, maybe device, MAC, then partner. You see that if you go to my field list here, all these fields that I'm specifying, they are available here on the field list on the left. So I'm just saying that pull my events and make sure that only these fields are included in the event. So I'm going to go maybe node name, caller number, and then I'm going to do zip code. So when I execute this, you see what happens now. It's still pulling the 23,000 plus events. But if you look at it now, only specific fields have been pulled for each event. If you go to each event now, instead of that long list that we had in it originally, you see that each event is limited only to the fields that we have specified. And this is a distributable streaming command, as we saw. So the expectation is that this command is being executed on the indexer. And this is very important. Imagine that with all these fields, you had field extractions that was going to take place. When you limit with this, field extractions is only going to be performed with this limited set of data. So it's going to help with your resources. Okay, now the next thing we are going to do is to use the eval command that we saw already in the pipeline. So the next distributable streaming command, we're going to use the eval command. So the fields command has limited our data. We got the first set of intermediate results, which is what we have here. So now we are going to apply the eval command. The eval command is only being applied on what we have, not the original data from the index. So when we apply the eval command, it's going to give us the next set of intermediate results. I'm going to go eval, and what we want to do is to calculate a new field called call result, just as we saw on our pipeline. And we are going to do this using the if command. So basically, using the if function. Sorry. So the eval command in association with the if function in order to calculate a new field called call result. So we are going to say call result is going to depend on another field called response code. If response code is 200, then we are going to give the call result a value of success. Else, we give it a value of failure. Again, these are all commands that are documented in the search manual. So we're just going to look at them here high level. So basically what we are saying here is that give the call result success if response code field is 200. And where's the response code is here. So everything that has 200 will be considered success. Everything that has anything other than 200 is going to be considered a failure. So when I run this now, what you notice is that you have the call result here. You see that you have about 60 something, close to 61% of events that are successes, and then maybe like 39% of events that are failures. So that new field has been added. So now your next set of intermediate results is what we had before plus this new field here. Okay, now we are going to use another distributable streaming command. Again, at this point, everything is executing the index. Since we are using another command in our pipeline, we put a pipe character again. Okay, so the next command in our search pipeline, we're going to use a command called the rex command. So this is a command that is going to calculate new fields using regular expressions on existing fields, or maybe on the raw data itself. But you have to specify which field you want to use for your regular expression. We're going to go here, for example, and you can look at this column number. These are just events that we generated using the event gen app. It's not really like a standard numbering, North American numbering plan that is going to be 10 digits with the +1 in front of. So these are just 7-digit events that we generated. But what we're going to do here is that we're going to pretend that these first 3 digits here represent the area code of the caller number. And then we're going to extract these first 3 digits and put in another field that we're going to call caller area code, for example. So there are different ways of doing that. Right, we can use substring with that, and which is another function. But here we are just going to try and use a regular expression because we want to use a distributable streaming command. So I'm going to go here, and when you do rex, which field do we want to perform that regular expression on? Is the field caller number. So I'm just going to copy it here and paste here. And then after that, now it's just a matter of syntax. So here is because I've used the command, I understand the syntax. Again, you just have to find this in the documentation. So you're going to do this. And then the new field that you want to calculate, I'm going to call it caller area code. And then I'm going to say that take 3 digits. So that's how the digits is represented in regular expressions. So this means 3 digits. So the first 3 digits of this field is going to be put in the caller area code. And after you take 3 digits, how many digits follow that field again? So if you go there, you see that there are 4 digits that follow. So you can go there and just put 4. I think it works even without that, but I'm just going to put here that and say that followed by 4 digits. And then we have to if we put that followed by 4 digits, and it means that if for some reason there was a field that had a caller number that had 8 digits, which is the wrong syntax in our case, because we are saying it's always 7 digits, it's not going to work for that. So we're saying that 3 digits would be called the caller area code, and then has to be followed by 4 digits and then end. Anyway, that's just regular expressions right there. So when we run this, we're going to see that now you have a field called caller area code that has the first 3 digits there. So that's another example of a distributable streaming command that you can use. We're just going to go ahead and try another one here. So let's suppose that we are looking at this command, this field here, node name, and we wanted to really call it host name. We didn't want to call it node name. So we can go ahead and use the rename command. We saw that rename command is also a distributable streaming command under the right circumstances, because if we are renaming a field that is already available in the statistics table, then at that point it's going to execute on the search head. So I'm just going to go here and say that my node name, I'm going to say rename node name as host name. So I'm still writing stuff on my pipeline. You see that node name is no longer available now. It has been changed to host name. And then I'm using the rename command here with the as clause. Remember, we saw clauses. We say you can use clauses to rename fields or to group fields. So we're going to see how we can use the clause to group fields somewhere along the line. So you see that the node name field has now been renamed to the host name field. We're going to look at our last distributable streaming command here in our example. That doesn't mean that those are the only ones that are available, but those are the ones that we are actually just demonstrating here for you to see how things work. Now we look at the lookup command. I'm going to start by just duplicating this screen here. There is a lookup table that we already have here in Splunk. That's the lookup that we used in our courses, the Splunk Core Certified User and the Splunk Core Certified Power User, and it's called zip code, I think zip code mapping. Here it is. So what this lookup really has is it has information about each zip code and which state county. This is lookup. So we use this generating command. We're going to talk about generating commands in this demonstration. So let me just say this pulls the content of this lookup. You see that this lookup table has a zip code, but then it's telling us that each zip code, it tells us the state where it belongs, the county where it belongs, and then the city where that zip code belongs. What we are going to do now is tie the zip code in our lookup table with the zip code value that we have in our events here, and then add this fields here as external fields into our event. So we can do that using the lookup command, and it's a distributable streaming command. So I'm going to go here and just say lookup. And what am I looking up? I'm looking up this lookup table here. So I have to put the name of my lookup here. And then I have to put the field in the lookup table that I'm trying to match with my data. So that field is zip underscore code. So I'm just going to put it here, zip on this. Note that this is case sensitive, so you have to make sure that it's precise. And then that zip code mapping matches this other zip code in my data. So I use the as clause here, and then I do zip code. Okay. When I execute this, what happens? You look at the data now, you see that, oh, it has actually added the city, it has added the county, and then it has also added the state. So if you look at each event now, you see that each event now has a value of city, has a value of county, and has a value of state. That is how you use lookups. And this one actually executes on the indexer. Now, there is a way that I could do, if I, for example, I didn't want to output the county, maybe I just wanted to output the city and state for that lookup, I could just come here and say output, output city, state. Then in that case, it goes into that lookup, but it's not going to output all these three fields here. City, county, state is only going to output the city and the state, but that's what I decided to do. If I don't have that limitation, then it's going to output everything. So you see here that city, state, but you don't see a county. So that's just how you can use some distributable streaming commands. And when you use it this way, the lookup command is going to execute at the indexer. Now, what about orchestrating commands? We said for orchestrating commands, it just kind of controls some behavior, but it doesn't really changes anything with the results. That's what we said. So if I come here and just use local equals true. So what I'm saying is that do not execute this lookup command on the indexer, execute it on the search head. It has no impact on the results. The results are still going to be exactly the same thing that we had, but just that this lookup at this time is going to be executed on the search head. We saw an example saying that maybe you had some kind of issue with your knowledge bundle. Lookup is still going to work because you are doing it on the search head. That if you attempt to do it in the indexer, when you have issues, their replication bundle is not going to work. So that's how you can use distributable streaming commands. And we've also seen how you can bring in an orchestrating command here, just controlling the behavior of the lookup in order to have it execute rather on the search head. Okay, now what about centralized streaming commands? We said these commands are also going to be executed on each event, but the only difference is that the order of the event matters. For distributable streaming commands, the order does not really matter, but for centralized streaming commands, the order matters. And an example that we saw there was the head command. So if I go here, for example, and then just say head, so look at what happens. If I look at my events now here, you see that it just pulls the top 10 events. Look at it's 10 events because that's the default. So when I use head without any passing in any arguments to it, it's going to pull the top 10 events. And these are in reverse chronological order of time. So you can see that the latest event is going to be first, and then it's going to decrease in that order. So that's how you can use the head command. But again, in order to use the head command, all the events need to be in a certain order. So the order actually matters, because if you don't have an order, then how are you even going to pull the top 10 events, right? But you can make changes, like maybe you pass an argument like 15, that I want the top 15 is going to give you 15, or maybe 20, you know, it's going to give you the top 20 events. So that's an example of how you can also use a centralized streaming command. So the head command is actually a centralized streaming command. Now I'm just going to disable this line here by commenting it so that it doesn't act on the data. And then I run this. So we have everything up to this point. I'm also going to make sure that this lookup here executes on the indexer and not on the search head. So up to this point, we have just run distributable streaming commands. Okay, so what I'm going to do now is that I'm going to move forward, and then we'll look at how transforming commands actually work. We said transforming commands on the pipeline are commands that are going to organize our data into statistics tables. So when you see this data has been pulled, we've actually executed all these distributable streaming commands. If you go to statistics, you see that there's no table there. There's actually nothing. You go to visualization, there is nothing. But if you execute a transforming command, you are going to see that it's going to change that behavior. So let's go here first, and I'm just going to say starts, which is a transforming command. I'm going to use the count function, and then I'm going to use the by clause and say call result. So I'm saying that count the number of events and group by call result. And call result, we said what? It has the value success and failure. So when we do this and just run it, then you see that. See the way it breaks everything down. So it says in the last 60 minutes, you have like 8,900 failures and close to 14,000 successes. So now you see that the statistics, now everything has just shown you what's on the statistics tab, because it's been populated now, because you have a transforming command. And then you go to visualization now, you see that, yeah, it has a default visualization there, which is a column chart for you. So it's saying that failures, you see 8,900, and in successes, you see close to 14,000. That's just because you have used a transforming command there. And that's the difference. In this case, now, if you go to events, you're not going to see anything. But if you really want to see events, then you have to change your search mode here, which is also something that is discussed in the Splunk Core Certified User course. So if you go to verbose mode here, you're going to see both your events, and then you're going to see your statistics as well. But if you go to fast mode or smart mode, you're not going to see the events when you run a transforming command. You're only going to see the statistics. Okay, so now we are going to just change this. I'm going to comment this line again, and then I'm just going to go to the top command. So instead of saying that, for example, now we wanted to do this same command, and then we wanted to look at both a count and percentage. So we see the count of events by result code. We also want to view the percentage by result code. I could actually do that through some calculation, but the top command is a command that is available. It makes it easy for us to do that. So if we just say top call result, this command by default is going to give you the count and percentages. So you see that it says for success events, you have close to 14,000 here. And then for failure events, you have, close to 9,000 or so. And then these are the percentages, 61% here, and then 38% here. So that's also an example of a transforming command that you can use there as well. Okay, so we've seen that with transforming commands. Again, you can go to the visualizations tab, and then you're going to see your visualizations there. Now, let's try to go and look at another important transforming command here. we're going to look at what we call the time chart command. So I'm going to comment this line again. And by the way, all these transforming commands, the expectation is that they are executing on the search head. So when you get that data from the indexer, now all the data is pulled to the search head, and then you're going to execute these transforming commands there. So the next one I'm going to do here is a time chart. I'm going to say time chart. I'm going to give it a span of, say, 5 minutes. And then I'm going to say count by partner. And then just run this in the last 60 minutes. So the time chart command is discussed in the Splunk Core Certified Power User course. When you execute this time chart command, by default, it puts time on the x-axis, and then it's going to put the value of your function here on the y-axis, because here we're using the count function in association with the time chart command, and here we are using a time bucket of bin of 5 minutes. That just really means that it's going to give you a sampling interval of 5 minutes. If you look here, you see 1:55, 2 p.m., 2:05, 2:10, 2:15, 2:20, and all that stuff. And if I do this and say I want to get 15 minutes breakdown, so I change my sampling interval to 15, you see that it's going to go from 1:45 to 2 p.m. to 2:15 to 2:30, and so on and so forth. Again, when this is discussed under the Splunk Core Certified Power User course, it's made very clear, because we explain all these different arguments there as well. Now, when you look at it, it's showing you here, this is a column chart, that's the default. But maybe you don't want to view this as a column chart. You really want to view it as something else. You can go to your visualizations here. You can change that. So let's do area chart, for example. Okay, does it look very cool with area chart? Some areas may be hidden under others. Maybe you might not be able to interpret it that well. So let's go and say, okay, you know what? Let's use the bar chart. Well, the bar chart doesn't look, it even looks worse, right? So you don't really understand what's going on there. And then we can go ahead and say, okay, let's use the line chart. Oh, yeah. The line chart kind of looks like the best chart in this kind of situation. So you see how the count of event varies for each partner, telco 1, telco 2, telco 3, 4, up to telco 7. Now let's see how we can use a data processing command. What I'm going to do here is that I'm going to comment this one again, and then I'm just going to go do simply start count by partner. Just something like this. So you see that, or move away from visualization, I will go to my statistics table. So you see that it's giving me the count of events by each partner for the last 60 minutes, of course, because that's what we have here on our time picker, right? So we see here. Now, a good example of the data processing command is what we call the sort command. We said these commands, you have to pull all the data before they execute. So you go here and then you can just do sort. So you have it here, but you see that these are random. Maybe you wanted to do it in such a way that the highest count shows at the top and then the lowest at the bottom. Or maybe the smallest at the top and the highest at the bottom. So if you just do sort count, because you have a partner field and a count field. So if you say sort count, you see that it sorts it out in such a way that the smallest is at the top. So you have 902, 13 that, 2000 that, and so on, and then 6605, which is for telco 4, is at the bottom. Now, if you want to sort in reverse order, you can use a minus here. So it sorts it in reverse order. Sort command again and the stats command, they are both discussed in the Splunk Core Certified User course. So you have that, you have the highest at the top here, followed until you have the lowest at the bottom. And you can decide that you want to sort by partner names too. So you can just say sort in reverse order of partner. And then you're going to see that partner number 7 is at the top, 01 is at the bottom, and then you can say sort in ascending order of partner without using the minus, so the negative sign there. Then it's going to sort telco 1 to telco 7 like this. So that's how you can use a data processing command such as the sort command. Okay, now another command type, we've discussed distributable streaming commands, centralized streaming commands. We've discussed transforming commands. We've seen the data processing command just now. So we're going to go ahead and look at what we call generating commands. Now, I already used a generating command, so I'm just going to go to the tab here. We said you can use generating command to get information, data from like indexes, from data models, from TS, IDX files, and so on. So in this case, I have a lookup table here, and I want to see what is part of the lookup table. So I use a generating command known as input lookup on that lookup table, and then it shows me the content of the lookup tables. And remember, we said that for generating commands, they always start with a pipe at the beginning. So that's what you have. Now that takes us to this. Let me go back to what we had here. I'm just going to duplicate this again. I'm going to go here and just say that we go back to our main index equals main source type equals event gen. So when we run this, last 60 minutes, I think that's why it was taking long. Let's just do 60 minutes. Isn't this pulling data from the index? But we said generating commands, pull data from the index. Where is our generating command here? It's nowhere to be found. We say, oh, we just use this to pull data from the index. That is because it is implied. So in reality, it is this. So we are using the search generating command in order to pull that. So you see that if I run that, it doesn't give me a syntax error. It just kind of reduces to index equals main source type equals event gen. So when you are pulling your data from the index using your search terms or field value pairs or whatever, the search command is being implied. So that is the command that you are actually using to pull that, but you don't really need to specify it explicitly. And this is sometimes a question in the exam, which says that which command of this that you don't have to explicitly specify, which command is implied. So the search command is generally implied when you're using search terms in order to pull data from your index. So that's just how the search pipeline actually works. So this is a complete pipeline here where you can see that you're using different types of commands and functions and clauses and stuff like that on the data that you are pulling from your index. And then we have seen the different kinds of commands and how they apply. And the most important thing, as we said, make sure that your distributable streaming commands always come first when you pull data from the index, because it makes you to write more efficient and less resource intensive searches. Again, as I said, for a coverage of these commands in the different courses, you're going to see extended discussions of the field command, the eval command, the rename, lookup, and all those different commands. Again, there are a lot of commands that are part of SPL that are found in the Splunk Search Manual online, and those are things that you're just going to learn continuously as you grow in your Splunk journey.